Hi there, this is going to be your Algebra 1 Chapter 3 review found on page 164 in your textbook. You'll still have another review for your Chapter 3 test coming up soon, but for now let's focus on these textbook questions. For number 1, it says determine whether the relation is a function and then explain. For number 1, the relationship is a function because each input has exactly one output. For number 2, that one is not a function because if you draw the vertical line test, it goes through 2 points in the graph. So this would be not a function. For number 3, that one is still a function because once again, like number 1, each input has exactly one output. Remember for this one, if you wanted to, and for number 1, you could also graph this to see if it passes the vertical line test, but you don't have to graph every single time. Just know that each input should only have one exact output. For the next section, in number 4, the function y is equal to 10x plus 100 represents the amount y in dollars of money in your bank account after you babysit for X hours. Identify the independent and the dependent variable. So the independent variable is the number of hours you babysit. So the dependent variable is the amount of dollars that you get. If we babysit for $4, we would find the domain in the 4 hours. Let's find the domain in the range of if I babysit for 4 hours, I can go up to 4 hours, but anything in between that could be working. So I could go anywhere from 0 all the way up to 4 hours. You can't go in the negatives because you can't babysit negative hours. So that would be the domain. And then the range would just be how much money you would make. So if you started out with 0 hours of babysitting, you would be at $100. But then 4 hours of babysitting, that gives you an extra $40. That's all the way up to $140. So your range should be 100 is less than or equal to y, which is less than or equal to 140. For number 5, it's asking, does the graph or table represent a linear or a non-linear function? Just remember that linear functions have to increase by a rate of change, either by addition or subtraction. So in number 5, this one would be considered linear because it has a constant rate of change. Up here at the top, we're adding 5 each time. And down here in the bottom, it looks like we are subtracting 3 each time. So that still gives us a linear function because it's increasing the same amount every time. For number 6, however, this is non-linear. It is a function, but it's not a linear function because linear functions need lines. So just make sure whenever you're looking for linear functions, it makes a line. And that's kind of easy because linear starts with the word line. Next up, we're going to look at number 7, and this one also represents a function. Y is equal to 60 minus 8x, and the amount y in dollars of money is after you have buying X movie tickets. Find the domain of the function would be for the first part, and then we'll talk about is it discrete or continuous. So the domains that you can have here can be any whole number. So we can have 0 tickets, 1 ticket, 2 tickets, 3 tickets, 4 tickets, 5 tickets. So here are my domain options once again. Now I can go ahead and figure out if this is discrete or continuous. And this one would be discrete just because you have to use whole numbers and you can't use in between amounts of buying movie tickets. The next part we're going to do is we're going to graph our function 60 minus 8x. So what we maybe want to do is just create our table of domains, plug in these amounts, and then see what we get. So here are some values that I'm going to use. And since I have a wide range of values, I think I'll use probably just to go up by 6s on my y-axis. And I don't need any of the other quadrants because everything I have is a positive. So you do not need to plot negative numbers. Let's go ahead and plot them to see what it looks like. So here are my values plotted. I would be good with this because I don't need to connect my points. If I did have a continuous domain though, I would connect the points. For numbers 8 and 9, you're essentially just plugging in x when it's equal to -3, 0, and 5. So what I did is I went ahead and plugged in all of the x values for each one. In number 8, when I plug in a -3, I will get 5. When I plug in a 0, I get 8. And when I plug in 5, I get 13. Over here, though, in number 9, when I plug in a -3, 3 times -3 is -9, so 4 minus negative, that's going to change to 4 plus 9, which is 13. If I plug in 0, that's basically 4 minus 3, which is a 1. Just kidding, I forgot to do order of operations there. So you should multiply first. That's going to give you 3 times 0, which is 0, and 4 minus 0 is 4. The last one, when we plug in 3 times 5, we get 15, so we're basically just doing 4 minus 15, which is -11. Okay? For number 10, you're just plugging in the k of x or the r of x and then solving for x. So I would plug in 49 for the k of x and then solve for x. So 49 is equal to 7x. I'm going to divide both sides by 7, so that x is equal to 7 for number 10. For number 11, I'm plugging in 19 for r of x, so 19 is equal to -5x minus 1. I'm going to add 1 to both sides, so I get 20 is equal to -5x, and then divide both sides by -5. X is equal to -4. For numbers 12 and 13, you're graphing the linear function. What you could do here is just make a table of values. So here's what I have for g of x when I plug in -2 all the way to +2. Since this is a linear function, I should have the consistent rate of change, and I should also bring a line to it whenever I am done graphing. Here it goes. So here are my points, and then last but not least, I'm going to connect my points so that I have my appropriate function. Over here in number 13, if you wanted to still use the table, you can, or you could use slope-intercept form, where you have your y-intercept, and then here would be your slope. So your y-intercept is at +4, 1, 2, 3, 4, and your slope is a positive, so we would rise 2 and run 3. So up 2, I'm going to show you my rise, and then my run would be 1, 2, 3. So here would be your new point. I'm just going to erase what I have. To show another point, we can go fall 2 and then to the left 3. So just like a mirror image, and again, it should be a consistent rate of change for each one of those. Okay, so that's just another way that you could try it if you'd like to. For number 14 and 15, we're graphing the linear equation, and since you have x's and y's on the same sides, you can probably use x-intercepts and y-intercepts to graph these. Just remember, if you're trying to find the x-intercept, you're going to plug in 0 for y. So that would look like this. So I'd have 8x minus 4, parentheses 0, is equal to 16, which is basically 8x equals 16. So x is equal to 2. So I come over here on my x-axis and plot the 2. And then I do the same thing for the y, but instead I'm just going to plug that in 0 for the x. So 8 times 0 minus 4y equals 16. Basically that's -4y is equal to 16. So y is equal to -4. So on my y-axis I have 1, 2, 3, 4, and then I connect my 2 points. Okay, for number 15, I can do the same thing. I'm going to get my x-intercept first. So I'm basically plugging in 0 for y, which cancels out the y. So I have -12x equals to 36, so x is equal to -3. So find -3 on the x-axis and plot my point. And then I do the same thing for the y. -3y, because the 0 with filling in for the x cancels out, is equal to 36. Y is equal to -12. This one's actually going to go off my graph just a little bit because I only go up to 10 here. So it'll be way down here. 10, 11, 12, about here. And this one is going to be super steep as we have that one. I could have actually made my graphs maybe be an interval of 2s or 3s. That might have been helpful, but I didn't think that through before I did. So that's what it should look like for number 15. 16 and 17, those are really easy because you're just plotting the -5 on the y-axis and the +6 on the x. So 16 would look like this. 1, 2, 3, 4, 5. Remember, you want to draw a horizontal line to show where that point is. And then 17, you're just finding a +6, 4, 5, 6. And again, that one will show a vertical line of where the x point is. For numbers 18 through 20, you're trying to find the slope of the line because the points on the table do represent a line. So just remember, we're using, for this one, y2 minus y1 over x2 minus x1, or basically the change in y over the change in x, or rise over run. You do need to have this memorized, so make sure that you're ready to use that for your test. I always just use the first two y's, so I'm going to do 15 minus 9 for number 18, and then 11 over 11 minus 6. 15 minus 9 is 6, 11 minus 6 is 5. So for number 18, I should get 6 over 5 for my slope. Number 19, I'm just going to use, again, the first two. So I'm going to do -2 minus -5. Remember, you do the minus negative for that. Don't forget it. And then for x, I'm going to do 3 minus 3. -2 minus 5 actually changes to -2 plus 5. So that would give us 3, but then 3 minus 3 gives us 0. And since 0 is on the bottom, our number 19 would be called undefined. For number 20, I'm going to do -1 minus -1, and then -3 minus -4. That's going to change to -1 plus 1, and then -3 minus -4 would change to -3 plus 4, and that's going to give me +1, but this would be equal to a slope of 0. So 0 is my answer for number 20. For 21, we're graphing the linear equation and identifying the x-intercept. This one's already in slope-intercept form. So I'm going to use slope-intercept to graph. Intercept. So my y-intercept is +4. So I'm going to go up to +4. And then my slope is 2. So I'm going to rise 2, run 1. Rise 2, run 1. And notice I'm getting further away from the x-axis, so I do need to bring it back down. So I'm going to fall 2 and run to the left 1 until I get to the x-axis. Okay, so there's my x-axis. Here's my slope, rise over 1. If you don't like slope-intercept form, remember you can just make a table, and that could help you as well. Just make sure your y's and x's are on the same side, or just find your y and x-intercept. For this one, your x-intercept is at -2. Okay. For number 22, this is not in slope-intercept form, so what I could do is just use my x-intercept and my y-intercept for this one. I'm just going to use basically what's easiest for me to graph. So when I plot my, when I try to find my x-intercept, remember that's x is there, but y would be equal to 0. So -5x plus 0 is equal to -10. So basically -5x equals -10. X would be equal to a +2. So there's my x-intercept. And then my y-intercept, I'm going to do the same thing. When I plug in a 0 for the x, that basically goes away, so y is equal to -10. So that's all the way down here on the y-axis. And then I plot my points. It's a really steep incline, and my x-intercept is at 2, 0 for this one. Okay, so you can use whatever you like best, table, x and y intercepts, or using slope-intercept form for these two. The next one, we're again graphing the linear equation, identify the x-intercept. This is not in slope-intercept form, so I'm just going to find my x and y intercepts by plugging in 0 for these. So x is equal to 9. There's already my x-intercept. And then my y-intercept, I'm going to make x be 0. So y is equal to 3. 1, 2, 3. And then I connect my points. And my x-intercept is at 9, 0. For number 24, this one is talking about a linear function, and we are going to graph it, so I'm going to get a picture of a graph on here. And what we're looking for is the independent and dependent variables. It says the dependent variable, which is always your y, or your slope, or sorry, it is your slope. It decreases 2 units for every 3 units. So your slope is -2 for every 3 units of x. So that would be y over x, which is your rise over run. And then it says graph h when h of 0 is equal to 2. So 2 is your y-intercept. So we'll just graph starting at y is equal to 2, and then we use your rise over run 2 over 3. So we have down 2 over 3. So down 2 and then over 3. 1, 2, 3. Down 2 over 3. 1, 2, 3. Okay, and then I'm just going to erase my little tracks that I put down here. Okay, and then it also says identify the slope, y-intercept, and the x-intercept. I do have the x-intercept now that I've graphed. My x-intercept is at 3, so I can rewrite these. My y-intercept may be at 0, 2, and my x-intercept would be 3, 0. I have already identified my slope as -2 over 3. Just remember, a dependent variable represents y, independent variable represents x. That was a y over x, which again is rise over run. And just make sure you pay attention to decrease, because that would be a -2, and increase would be a +3. Okay? The last one is maybe the trickier one that we've talked about with lesson 3.7. It gives you your absolute value equation in Vertex form, and it says describe the transformations of the graph, and then graph the graph of G. Remember, I'm going to consider the letters K for a translation or a transformation, the letter H I'm going to consider, and then the letter A I'm going to consider, because that'd be on the outside of the graph. Okay, I'm going to start with letter K. So letter K is this -2 right here, and because it's negative, that's going to be translating 2 units down. Okay, so translating 2 units down because K is a -2 at the end. Then I'm going to look at my H. Remember, my H is in here. I do want my parent function to be able to equal to 0. So if I want my parent function to be able to equal to 0, what -1 can give me 0? That answer is 1. So since H is positive, it would shift to the right 1. That would also be a horizontal translation. The other thing I'm going to consider is A, which is the very beginning of my absolute value, and A is equal to 1/3. Remember, if A is in between 0 and 1, that's going to shrink closer to the x-axis. So this would be considered a shrink of 1/3. Okay, now I'm going to be ready to graph these. So I'm going to kind of erase my markings here so we can see that equation clearly. And all I need to do is just find points that would be easier for me to graph. Because I do know that it's shifting 1 to the right, I know 1 will need to be my vertex for an x point, so I'm going to use that. And then I've used some points 4, 7, and 10, because I know if I subtract a 1 from 4, 7, and 10, it can be easily multiplied by 3. I did need to change my negative values because I realized I was going up by 3, so I needed to show the same thing with my negatives. So here are now my values. Now I'm ready to plot my. So here are all my points, and I'm going to connect all my dots so that I have my absolute value equation. That is going to conclude all of your review questions from your textbook. Thanks so much for tuning in and being patient. Good luck on your Chapter 3 test, and we'll keep reviewing over the next few days.